Hi everyone, welcome to another edition of Designing Your Own CNC Mill. This particular episode, I'm going to focus on an existing mill I have, which is this Taig, what we can learn from it and apply that to designing the Granite epoxy mill. This particular mill is my Taig CNC, and it's apart right now because I took it from my home to my workplace and I took it apart to fit in the car. So this is the column and this is the base. And I actually just purchased this aftermarket frame, which is a really big improvement. And it's made by Stuart Andrews. He's on the Taig Facebook group. So if you're interested in buying this aftermarket frame for your Taig, he has a post on there letting him know how to order it. So this is the frame as received. And I'm going to make a modification to it, which is the same modification I'm planning to design into the Granite epoxy mill. And it will be a tramming provision between the column and the base using epoxy. So this particular design, this is machined very accurately, and if you do need to tram it, the recommended method is to use a couple of shims, 1 or 2 thousandths thick, wherever you need it. But I want to do it with epoxy. Even though it might not need it on this mill, it's more of a practice so I can use it on the one I'm going to design from scratch. Here's the surface, and these 4 screws, these 4 holes, I added. They weren't part of the original design as I bought it. I added, and inside each of those holes is a set screw, 1/4 Most set screws are cup point that dig into the material. This is a flat point, so it won't dig into the material. The set screws you can raise and lower, and when you raise and lower them, they will push on the bottom surface here, on the 4 corners, and you can adjust your tram that way. And once you have everything where you want it, I'll pour in epoxy on this surface and this surface. After the epoxy cures, tighten everything down. Here is my setup to see how much the frame deflects. So I have an indicator stand. It's an old Starrett, it's probably 50 years old, and a brown and sharp indicator. Each division is 1/2 thousandths. And I don't have a magnetic base, so I made this strap clamp that keeps the indicator secure. And what I'm going to do is I'm going to push on this and see how much the indicator moves. When this is completely secured and this surface is fully touching this surface as it's designed. So the set screws are in there right now, but they're backed all the way out so they're not touching. So that's going to be my baseline. Then I'm going to repeat the same test by raising the set screws so there's a small gap here, maybe 1 millimeter or 40 thousandths of an inch, and tighten these screws, and then do the same test. Push here, see how much the indicator moves. And then I'm going to do a third test, which is squeeze epoxy inside here, and after the epoxy cures, clamp everything down again, and then push again. So the goal of this is to see, does the addition of epoxy as a tramming agent cause more deformation of the column as you push on it, because the epoxy is softer than the steel, so it's going to compress more when there's forces applied to it than the steel, and any compression down here will show up as more movement on the indicator tip up here. That's the goal of this experiment. 3 different experiments, and see how each one affects the movement. So I'm on the 10. Let's see if it repeats. I'm just going to push on it with my hand. And I let go, it goes back to 10. I'm leaning into it as hard as I can. Let it go, it goes back to 10. Okay, so it seems our setup is pretty good. This is what I'm doing. I'm pushing here, and I have the clamp here. So we're starting at 10 on the brown and sharp. I'm leaning into this as hard as I can, so it moved 2.5 thousandths. And I let go, it goes right back to 10. Try it again. It's at 7.5 thousandths. Let it go, goes to 10. One more time. 7.5 thousandths, goes to 10. I do have a force gauge. My original plan was to push this on it and see how much the needle moved, but I'm gonna slip right off if I try pushing this, and I won't be able to see the number anyway. And I think if I just push this as hard as I can, it's probably good enough. I'll also mark where the indicator tip was. In case it moves. Seven and a half. Yeah, so that's as far as I can push it. 7.5 thousandths or 2.5 thousandths of deflection. Now my setup, I have a gap in here. It's about 50 thousandths of an inch. So the column is resting on the set screws here, on the 4 set screws, and then the clamp screws are really tight. And the rest of the setup is the same. And here you see we're on 10, so I'm just gonna see if it repeats. 10, 10, okay. It moved to 4.5, it moved to 4, moved to 4.5. So that was, it moved to 4.5 on an indicator, so that was 5.5 thousandths of movement. And it repeats to 10. With the column resting on the set screws right now, it's moving 5.5 thousandths of an inch when I push it as hard as I can. When the column was firmly clamped to the base and the set screw gap was 0, with the same force, or roughly the same force, I could move it half as much distance. So this is definitely weaker than what I had before. Now the question is, when I fill this with epoxy, will it go back to where it was, or will it be even worse than it is now, or somewhere in between? So that's what we're gonna find out. I just took the base and the column apart. So there's the base, and here's the column upside down. Here you can see depressions from the set screws. So here is the set screw I used. It's a flathead set screw. This is the reason I didn't want to use a cup head set screw, because it would make an even bigger depression. So with this flathead set screw, the surface area looks to be too small to withstand the force, and the material yielded slightly. I believe that was the reason that we had more deformation with the set screw setup compared to the non-set screw setup, because this material was deforming. So when we put epoxy on this whole surface, the force will be spread over a much larger cross-sectional area, and that will make the pressure or the stress much less on the material. Hopefully that's enough to solve the greater deformation that we experienced with this setup. And just by feeling this with my fingers, I'd say it's about 3 thousandths of an inch depressed. Here are the 4 set screws. They don't look like they have any damage to them. This setup here, I was experimenting with mold releases and what it would take to get the JB Weld epoxy off of the column and the base if I ever needed to move the mill, which of course is going to happen. So what I did is I just had the scrap of aluminum, I mixed up some JB Weld, and over here I had nothing applied. Over here I had Johnson's paste wax applied, and over here I had this silicone lubricant I got from Home Depot. I already took these off, so I just bent the plate a little bit and scraped under them with a razor blade till they popped off, and they all came off extremely easily. with nothing there. It came off, but left some on. The wax came off 100% clearly. And then the silicone blaster came off about the same as nothing. So the wax was a clear winner here. Okay, the 4 screws are waxed. The top of the base is waxed, and the bottom of the column is waxed. And also the set screw surfaces are waxed. So the setup will be like this. 4 O-rings on this side, nothing on the other side, and we'll see if it makes any difference. Off camera, I mixed the whole bottles of JB Weld, and I also added wax to the rubber O-rings. It's hand tight against all the set screws, and it looks like some epoxy came out from all the sides. I should have put wax on the outside of the frame too, so the squeeze out won't stick. So this is it. I'm gonna leave this, it's Friday. I'm gonna leave this over the weekend, and I will be back on Monday to see how it did. It's Tuesday and I'm back in the shop, and here's what it looks like. So the washers got squeezed out a little bit. That was good. Glue squeeze out all the way on the front, the side. The left and the back also have glue squeeze out, so it should have pretty good coverage underneath. The screw looks clean on the sides of the rubber washer. On this side we didn't have any rubber washer, and they also look pretty clean. Here's the back, that looks good. So the left side, we have some voids here and here. The front, it looks completely filled. And on the right side, we have voids here. And I think over here. I'm gonna do the push test again, pushing on here. And this is with these partially tight, exactly the way it was when I put the epoxy, but I didn't have these really tight against the set screws. So I want to see just filling that gap with epoxy, but not tightening this further, if that changes the reading here. Okay, I'm right on 10. Let's bump it a little, see if it repeats. Yeah, it's a hair under 10. Okay. So I can get about 4.5 thousandths of movement. Now I'm going to tighten these 4 clamp screws without loosening the set screws. See what happens. I'm going to try to tighten these and see how much the needle moves as I tighten it. Because if this were all trammed out and then I go to tighten it and it moves, then it kind of defeats the purpose. So it moved 1 thousandths there. Let's see if I can move 1 thousandths back. Moved half back, and we started on 10 thousandths. Okay, so while I tightened it, it clearly moved. It moved about 1 thousandths in either direction, maybe 1 thousandths and a half. And it started right at 10, Now we're at 9.5 when it's all said and done. So that wasn't very promising. Now I'm gonna move it again. Let me recenter to 10. Okay, it repeats. Here we go. That was as hard as I could. 2.5 thousandths movement. 2.5 of movement. 2.5 of movement. With these tightened all the way down and epoxy in the middle, and I didn't loosen the set screws, we got 2.5 thousandths of movement, which is the same amount of movement we got without any of my modifications, when it was steel versus steel and these tightened all the way and no set screws touching. So that's promising. Off camera, I just loosened these and made them finger tight. And now I can get the Allen key in here. And I want to loosen these set screws so there's no chance they're touching the plate at all. Okay, all 4 set screws are several turns loose, so there's no chance they're touching the upper plate. Now I'm going to torque these down again. All 4 clamping bolts are very, very tight now, and they felt solid, and the set screws are not touching at all. Okay, we're at 10. Check that it repeats. So let's do the same test. 2.5 thousandths. 2.5. 2.5, as hard as I can push it. So it looks like the epoxy, once it's clamped down fully, doesn't make the flex in the head any worse than it was without any epoxy at all and steel to steel. So steel to steel, I have 2.5 thousandths of flex, and now with epoxy inside, the bolts fully clamped and the set screws disengaged, I still have 2.5 thousandths of flex. The movement while I tighten the screws here is about 2 thousandths of an inch, 1.5, 2 thousandths of an inch up here. And then as I go between screws, you know, I can get it to move back and forth and end up about where we started. But I don't want that to move at all, because if the tram is all set and then you fill it with epoxy, and then after it cures, when you tighten the bolts, it's gonna move, well, that defeats the whole purpose. So I'm wondering, I was a bit concerned about this, because this frame has open slots instead of through holes. There might be some epoxy that didn't really fill this area. So as you tighten this bolt, it actually pivots on the edge of the epoxy, and it causes the whole frame to tilt a little bit. So with the one I'm designing from scratch, I'm gonna make sure these screws are inbound more so that there's epoxy completely surrounding them. And when the act of tightening the screw will be fully supported. There's not gonna be an edge of epoxy somewhere very close to the screw, so when you tighten this down, it causes any tilting motion. So if this screw, for example, was an inch in the direction of my pencil, and you tightened it, I don't think it would cause any tilting moments to the column. That's all. Thanks for watching. Catch you the next episode.